For this problem, when I entered this graph into the equation, I got a really weird looking graph, and I couldn't read the zeros very well. So one thing you can do when that happens is you can click on this window button, and after I looked at the initial window, I saw that if I looked at the x value starting at -4 and going up to 1, I'd have a better sense of what these actual zeros looked like, and that's how I'm going to start off with this problem. Based off this adjusted window, I can see that there's going to be a 0 at -3 and then somewhere between 0 and 1, but I'm not exactly sure where just yet. So let's go ahead and start with the obvious one, the -3. Following the typical steps for synthetic division, I do see that that is correct. And now, this is going to be some weird fractional value, and it seems like our only choices are either 1/5 or 3/5, and this to me looks more like 1/5 is a better bet, because 3/5 is a little more than a half, and this is definitely closer to 0. So I'm going to go ahead and proceed with 1/5, and this should work out just fine. You might need a calculator to help you with some of the multiplications, but it does end up being something exactly like this. This was 5x to the 4th, so this is 5x cubed, so this is 5x squared. There's no reason to write an x term if that term is going to be 0, and this is a problem we can solve by isolating the x squared and square rooting. So I'll go ahead and subtract the 5 from both sides. I'll divide by 5. That gives me x squared equals -1. So when I go to square root, I find that I've got two more zeros, and they're both imaginary. Plus or minus I is how I'd answer this. And so all the zeros would be -3, +1/5, and plus or minus I.